Alright, next we're going to talk about a change of variable for definite integrals, and you're going to use this when you use u substitution. So when using u substitution with a definite integral, it's often convenient to determine the limits of integration for the variable u rather than to convert the antiderivative back to the variable x and evaluate the original limits. Okay, so if we have a function u equals g of x and it's a continuous derivative on the closed interval a to b, and f is continuous on the range of g, then if we have our pattern recognition of f of g of x times g prime of x dx from a to b, what we can do is when we use our u substitution to get f of u du, we can actually change the limits of integration using our g function. So a here is going to become g of a, and then b is going to become g of b, and then once we find this integral, we can evaluate it using our new limits without changing the integral back in terms of x. Okay, so let's evaluate the following definite integrals using a change of variables. So if we look here, our inside function is right here, x squared plus 1. So I'm just going to call that my g of x, and that's going to be x squared plus 1. And then I'm also going to find my g prime of x, which is going to be 2x dx. Now when you look up here you see an x and a dx, but you can see we're missing a 2. So let's go ahead and rewrite that in. And we're going to do that by putting the 1/2 out in front. And we'll put this in order here. So x squared plus 1 cubed, and then times 2x, and then dx. Okay, so now if we look at this, we can really think of this as being our u right in here. So here's u, and then this right here is going to be du. So if we want to write this using u substitution, that'll be easy enough right there, but we also have to make sure to change our limits of integration. So we're going to find g of 0, which is the lower limit here. So that's going to be 0 squared plus 1, which equals 1. And then we're also going to find g of 1, so g at the upper limit, and that's going to be 1 squared plus 1, which equals 2. So I'm going to rewrite this using u substitution and change of variables. So we have 1/2. Here's the change of variable. So we're going to go from 1 to 2 of u cubed du. Okay, now we can use the general power rule for integration. So we get 1/2, and then the antiderivative here is going to be u to the 4th over 4, and we're going to evaluate that from 1 to 2. Okay, so just applying our fundamental theorem of calculus now, we're going to get 2 to the 4th over 4 minus 1 to the 4th over 4. And all in all, this is going to yield 15 over 8. So this change of variable is just a little bit of a time saver, because once we evaluate for u and we find that indefinite integral, we can just substitute in our new limits of integration without having to change u back into x squared plus 1 using the original limits of integration. Alright, let's try another one here. Alright, I want you to try the next example on your own. Go ahead and follow the same process, pause the video, and come on back when you're done to check your work. Alright, welcome back. Go ahead and check over your work here, and if you have any questions, please bring them with you to class. Alright, let's move on. Now for our next example, this integral looks a little bit trickier than what we've been dealing with. Here we can see the square root of 2x minus 1, and here we can see the x variable, and then we have a dx variable. So just for a hint, I'm going to let you know that u in this case can be the square root of 2x minus 1. So by letting u equal the square root of 2x minus 1, I now am able to rewrite this integral with u in the denominator. Now, if I want to know what x is, I need to solve this equation for x. So I'm going to square both sides, and we'll get u squared equals 2x minus 1, and keep solving for x. So it's u squared plus 1 over 2 is equal to x. So now I can rewrite this x in terms of u. So that becomes u squared plus 1 over 2. And now I need to find dx. And so to find dx, I have to differentiate both sides. Okay, so here's dx, and then if I take the derivative of this side, this would give me 2u plus 0, so 2u over 2, which is just u du. And so now I can rewrite dx in terms of u's. So dx equals u du. Now next, just to complete this u substitution and change of variables, we need to rewrite our limits of integration. Instead of from 1 to 5, it's going to be u evaluated at 1 to u evaluated at 5. So we're going to plug 1 in here. So 2 times 1 minus 1. And so that's the square root of 1, which is 1. And then if we plug in 5, we'll get 2 times 5 minus 1, which equals the square root of 9, which is 3. So now we're going to evaluate this from 1 to 3. Okay, so don't get thrown off here. This u is really g of x. It's the same thing. And so this was g of 1, and then this was g of 5 right here. Okay, so now we have this integral that we're going to try to finish off solving. Well, first off, we can simplify this a little bit because here's a u on the denominator and here's a u in the numerator. So that u over u cancels. And now we're left with integral from 1 to 3 of u squared plus 1 over 2 du. And we know the constant multiple can factor out, so we're just going to take that 1/2 to the outside of our integral. And this is going to be u squared plus 1 du on the inside. And now we can integrate. So we'll still have our 1/2. U squared will become u cubed over 3, and then plus 1 will be plus u. And then we want to evaluate this entire thing from 1 to 3. Okay, so we're going to get 1/2. Let's substitute in 3, so it'll be 3 cubed over 3 plus 3 minus 1 cubed over 3 plus 3. Okay, and when we evaluate this here, let's see, 3 cubed, 27 over 3, which is 9, plus 3 is 12. And then here's 1/3 plus 3, which is 4/3. And all in all, we end up with 16/3 here. Okay, I want you to try the same process here on our next example and see if you can follow my lead of taking the most difficult part and changing that into a u and seeing if that helps. Alright, so go ahead and pause the video and come on back when you're done to check your work. Alright, welcome back. Go ahead and just take a second to check your work. So you should have let u equal the square root of 2x plus 1, and that's our g of x. And then we need to solve for x, so we can rewrite this x in terms of u. So x was u squared minus 1 over 2. And then we need to write dx in terms of u. So we're going to differentiate both sides, and this becomes u du, and that equals dx. And then we need to change our x values into u values. So we find g of 0, which was 1, and g of 4, which was 3. And so we had the integral from 1 to 3 of our x, which is u squared minus 1 over 2, over u, and then times dx, which is u du. From here, the u's cancel. You can pull out the half. Okay, and then take the integral, so u cubed over 3 minus u, and this is from 1 to 3, and then apply the fundamental theorem of calculus and simplify, and you should get 10 thirds. So that's how to use change of variables for definite integrals.